Hello, my name is Aidan Arabzadeh, and this is the 555 time machine. The purpose of this circuit is to produce a square wave from the output pin of the NE555, and then to dive deeper and understand the inner workings of the chip which create the oscillation. These are the parts I used for the normal 555 and for the deconstructed 555, which I'll be going over in this video. The 555 can be built in three different modes: monostable, bistable, and astable, which is this circuit. This configuration provides an ongoing square wave, and these capacitors are used to clear up any electrical noise when transitioning from low to high. The name of the 555 comes from the three 5 kilo ohm resistors set up for voltage division, which is central to the function of the chip. 2/3 of the source voltage and 1/3 of the source voltage are presented at the junction points, offering fixed voltage references to the inverting input of the first op amp and to the non-inverting input of the second. The outputs of each comparator are also connected to the set and reset inputs of the set reset, also known as SR latch, which is essential for the oscillation to function. When the circuit is powered, current is through R1, R2, and then C1. As C1 starts to charge, pin 2 still has a voltage below 1/3 of the source and sets the latch, so the 555 outputs high. When C1 reaches a charge of 2/3 of Vs, the comparator on pin 6 turns on and the other comparator turns off. This resets the latch so Q0 is high and Q is low. Current is now through the base pin of the transistor on pin 7, which turns it on. This allows C1 to drain through R2 and then pin 7 because of the open transistor running to ground. When C1 drains to 1/3 of the source voltage, pin 2 carries the signal to the inverting input of the second capacitor, which sets the latch. That means reset would also become low. Q0 becomes low, and the output is high once again. So that closes off the transistor, and now the capacitor starts to fill again. This whole system repeats itself, and that is what causes the oscillation. At the end in the deconstructed circuit, a NOT gate is placed made out of NOR gates to just rectify the output. So let's draw this capacitor charging and discharging. So 1.6 volts, and let's see, this is 3.3 volts. The capacitor starts to charge, as we know, and then as soon as it reaches above 3.3, this resets the latch so the output goes low, and then that connects to the transistor and the capacitor starts discharging. And once it reaches 1.6 volts, that sets the latch once again so the output goes high, and now the capacitor can't drain anymore, so it's going to charge. It's going to charge all the way back up to 3.3 volts. So basically that is what is happening to the capacitor. It's just charging and discharging, and these comparators plus the SR latch are creating the oscillation. R1 and R2 both affect the duty cycle and the frequency of the square wave because the current is through both resistors when it charges, but only one when C1 discharges. On the other hand, C1 only affects the frequency because the greater the capacitance, the longer it takes to charge and discharge. With these values, we can calculate the frequency is 7.164 Hertz and the duty cycle is 50.25%. They are calculated using these equations shown on screen. With these equations, the operator can adjust the values of the resistors by using potentiometers, which is what I did in this circuit. So I can slow down the oscillation and speed it up, and slow down and speed it up. And you can change the value of the capacitor. This is extremely useful for countless circuits that require a clock, and is why understanding the 555 is a required foundation to build off in engineering. Thanks for listening, and I hope you learned something about the 555.